Hello, my name's Jonathan Hyde, a director from Risk Solutions, and I'm going to tell you a little bit about Savi, our rail performance model. This was developed as part of the Sandbox Plus program funded by Network Rail and RSSB. Savi is a groundbreaking computer modelling tool helping the railway industry to build a more resilient railway through a better understanding and management of performance and capacity risk. In normal circumstances, many parts of the network operate close to capacity. Combinations of small delays lead to more and more reactionary delay and longer times to recovery. Savi provides a powerful strategic decision tool helping train operating companies and Network Rail identify where there are potential risks to performance and then remove system fragility from timetables and service operation, creating a more robust and resilient system to improve service performance for passengers. We believe Savi is unique in two ways. Firstly, it introduces incidents and delays to the modelled services, so it provides more realistic interactions between the services. And then through interactive visualizations of model results, it allows users to identify risk more carefully and model potential ways to reduce risk and improve performance to find effective solutions. Savi produces a wealth of modelled data results. These include service delays, reactionary delays, attributed delay minutes, subthreshold delays, and Savi summarises these by location, by service group, by operator, by time of day. Savi also measures service lateness. This is arriving at station stops, as well as departure lateness and dwell times. These align with the CP6 performance measures. Savi models passengers on their journeys, so it records their destination arrival times and therefore lateness. And we have plans to introduce financial impacts of delay and emissions. As I mentioned, Savi produces an awful lot of results and modelled result data. So we've partnered with City University of London, and they've created some very powerful interactive visualizations that are part of the Savi toolkit, which users can use to identify the causes of poor performance, the root causes, and understand how they can improve performance. Savi's been designed so that it could be set up relatively quickly. So for example, within a month you can set it up for a relatively large TOC area or a region. It's been designed to produce multiple rapid model runs, so you can do sensitivity analysis on a what-if basis. Results are available the same day. Some examples of the things we've used it for: stress testing timetables, proactive testing of forward plans before timetable bids to check there are no serious issues with timetables, they'll perform as expected. Trying out different operational options, option analysis, focusing expensive trials where they're likely to give you the best chance of success. Exploring rare events and mitigating against them. And generating evidence for your performance improvement plans, quantifying the likely performance improvements that you're going to expect. Let me describe a little more about how it works. Savi is a data-driven model, so we generate model input data to characterize the particular bit of the timetable and the country that you want to operate over. So typically a region, a route, an area. Any particular day from a historic or future timetable can be modeled for any period of the year. Savi models all timetable services from all operators. It's a system-wide approach. This particular screenshot example is slowed down significantly so you can see trains moving around. Red trains are the trains with reactionary delay. Purple trains are at station stops. Blue trains are on the move. So with these trains, Savi introduces incidents characterized by historic delay data. And then it's the interactions and conflicts between the services that then cascade through reactionary delay. Let's give you some examples now of how Savi has been used from the Sandbox program. The first example I want to describe to you is one we did with Greater Anglia, who were interested in why during the COVID lockdown period there was such a significant improvement in service performance. So we modelled several interventions to reflect what we thought was happening at the time. The first was to remove all passengers from modelled services and all the attributed and subthreshold incidents that you would expect from passenger services. This did improve performance by 4% of on-time station stops, but not by as much as we had expected. So we had to look deeper. We then had conversations with people and realised that we could reduce the number of attributed incidents during lockdown as well. So we reduced the serious weather events, line side and network management incidents, and that also improved performance, this time by 8%. Lastly, we looked at reducing service frequency. We reduced freight services and passenger services from the timetable, and this had the most significant improvement in performance. The result was a 12% increase in station stop on time. Lastly, we combined all three together, and that gave us the final 17% improvement. Not quite as much as we needed, but we thought that demonstrates the way in which we could use Savi to explore the causes of performance improvement. Lastly, our conclusion was that sub-threshold delays had the largest effect across all of those examples, and that was a significant output and has directed Greater Anglia towards examining sub-threshold delays and follow-on work in more detail. The second case study we did with Greater Anglia was looking for disruptive services. In normal operation, which services cause the most disruption? And we identified 60 services out of the 3,500 running in the timetable caused 10% of all disruption across the region. And they were both Greater Anglia, and interestingly 2/3 of the services were from other operators. And so this gave Greater Anglia a steer as to which services they could focus their attention on. With Greater Anglia, we also did some work on timetable design. So we modelled the performance of a bid which is due to be submitted to Network Rail. This is for May 21 as it happens. The new timetable had some faster stock services and shorter journey times, and the concern was that maybe these would create additional station stop lateness. What we showed through modelling was that the new timetable should deliver the benefit of the faster journey times, but with a minimal additional risk of lateness. So I've described 3 of the 6 Sandbox Plus case studies. The other 3 were with GWR and with Network Rail. With GWR, we looked at service group poor performance, and we identified for one of their service groups some causes of poor performance so that they could focus their efforts to improve. With Network Rail, they were particularly interested in network capacity risk, so we looked at ways of measuring network capacity risk in a new timetable, in several options for new timetables, and compare those options to find the option with the least risk that could be taken forward for serious development. And lastly, with GWR, a new operator operating in the southwest, there were concerns that quite a significant number of new services were being added to the timetable, and this might cause knock-on effects for GWR service performance. We were able to demonstrate that the new timetable would not significantly increase lateness risk, but did highlight a couple of areas where Greater Anglia could develop some plans to mitigate hotspots of lateness. So what's the process of getting started with Savi? It's a 2-stage process. The first part of the process is setting up a new modelled area. So we use industry standard big data sets. After agreeing the scope with the users, we get the data and we develop and create the model input data that drives Savi. This characterises the area. We select the timetable to use, and we create a baseline and calibrate the model so that it reflects real-world performance. The second stage of the process is modelling service performance through scenarios like the 6 that I've just mentioned. So that's an iterative process, very close working with users to develop the scenarios to model, tweak the model, then do the model, and then do the analysis with the interactive visualizations to understand the causes of poor performance, and then repeat the process. Very close working with clients. If you're interested in finding out more about Savi, please do have a look at the RSSB website where the results of our work on the Sandbox programme are published, but also get in touch with Risk Solutions. I'd be more than happy to speak to you. Thank you very much.